Hello again. Milk the Code here with another day of the LeetCode challenge. Let me share my screen here. So we got 30 days. We're on day 3 now. After this will be a 10th of the way through. Let's see if the questions are going to get harder now. Let's see here. Maximum Subarray. This sounds a little familiar. Let's see what it is all about. Given an integer array nums, find the contiguous subarray containing at least one number, which has the largest sum, and return its sum. Okay, there's a few keywords in there. We've got given array of integers. Wait, am I recording? Okay. Given array of integers, find contiguous subarray of at least one number, so length of 1, which has the largest sum and return its sum. So we're not returning the subarray, returning the length of it. Let's take a look at this example that they gave us. Got -2, 1, 3, 4, 1, 2, 1, -5, and 4. And that yields 6. So the greatest sum of any of the subarrays within subarray, not subarray, of the subarrays within this array is 6. And that's because that array is 4, -1, 2, and 1. So an important thing to outline first, in case you haven't heard of this word contiguous, it means that, if I draw it, it'll be a little better. Let's draw it on a whiteboard. So if we had an array with like 1, 2, and 3, a contiguous subarray of it would be 1 and 2, or 2 and 3, just as examples. So basically it means that in the order that the array is in, there aren't any elements skipped between two indices. So basically, like if we wanted to have the subarray 1, 3, that would be non-contiguous because we're skipping element 2 here in the middle. So contiguous means that it goes in the order in an array, including all the elements between one indice and another one. Let's just clear that. Clear all drawings. So since this one is contiguous, let's take a look back at LeetCode. Wow, I'm really close to the camera. Okay, that's better. So we're back here, and we can see in here that we've got this subarray here in the middle. It is contiguous. 4, -1, 2, and 1. It's contiguous. So that makes sense now. I'm glad it isn't non-contiguous because that would make this problem a bit harder. Having it be contiguous is actually easier, in my opinion. Now the brute force solution is, I think it's n squared, because basically what you have to do is for each element, you have to compute the slice from that element to the end of the array, but each element within it. So like starting at -2. We'd have to go from -2 to 1, then -2, 1, -3, -2, 1, -3, and 4, and so on for each element in the array to the end to find out which one has the greatest sum. Now this will take a huge amount of time, and I'm pretty sure it's O(n) squared. But this question, it says, look for the linear time solution, so O of n, which basically means we're going to go over each element of the array once. So at most, we need to go over, in the worst case, we have to go over each element in the array, but we're not, basically we're not doing a nested loop. If we did this method, where we're computing the subarray for each element and another element, like between those two indexes, then that would be a nested loop, and that would be a huge jump in time complexity. So we need to figure out how to do this in linear time. So I'm thinking is we need to have a running count of the sum, and we need to have a let's just say pointer at current sum and a pointer at the max value, well, the max sum of any given subarray. We need to have those at all points. So let's draw this out on the whiteboard, because I just discovered this thing and I really like it. Let's see. Let's go with this. Oh, that's good. No. So let's go with, oh God, what is that? Let's go with their example. I think it's starts with -2 and 1, and then -3, and then 4, I believe. Okay, so we're gonna do this in linear time. We can only go one element at a time, and we can't do any nested loops for it. So let's assume we start with -2, and that is set to our max sum. I'm doing this on a trackpad, so if that's why it looks pretty messy, that's why. And our max is also -2, because it is a subarray. Technically, -2 can be its own subarray because it's a subarray with at least one element, -2. So our first iteration going over the array would be -2 and 1. So here's our subarray. And we want to compare it to the next element, because if it's contiguous, we have to take into account what the next element is. Now in here, we need to decide two things. We need to decide if we have a better shot at finding the max value by iterating from 1 onward, or by iterating from -2 plus 1. Because basically, if we say that, 1 second, my potato's about to go off. Oh, I got it.
Aren't you recording?
Yeah, it's all good.
No, it's okay. I got it. Did you hit pause?
No, it's all good.
You know you can hit pause on the record, right?
Oh, I didn't.
Are you trying to edit it?
No.
Really?
Yeah, it's all good.
you want me to hit pause on it?
No, it's all good.
They need more time.
Yeah.
I got it.
Potatoes look great. So we were at this first iteration, -2 and 1 as one subarray. So basically we need to decide if we want to keep iterating from the first element in the subarray, or if we want to iterate from the second element. Now in this case, since it's summing, we have to add these two elements together, which would give us -1. And we want to compare it to the next number. So it's -1 and 1. What do we do here? I'm thinking this out in my head right now as I'm coding. Kind of thinking of it as an interview where you're whiteboarding and coming up with things on the spot. So I think here we would take the max value between these two values. So here we take 1, which means that we're going to start iterating from 1 onward, and we're just going to forget about -2. If we had, for say, let's say it was, say it was 4 and 1, it would be, we do 4 plus 1 to get the new sum, taken into account the next element of the array, or, and then we also just put the next element in. And we compare those, and 5 is obviously greater, so we keep iterating from that first element, and we ignore this one, because we don't want to start counting from this one because it's less than the sum to the left of it. So we want to keep that within the contiguous subarray that we're creating as we sift through this array. Let me draw it out on LeetCode again. Once we have the example right in front of us. We got -2. I'll just copy this to make it easier. So the first one is -2 and 1. It gives us -1 versus 1, which is 1. So now our array looks like this. 1, -3, 4, and so on. Then we compare those. We have 1 and -3. And 1 plus -3 is -2. And the other number's -3. So since -2 is greater than -3, we continue iterating from that sum. So now our array looks like (1, -3, 4), and we are going from -2, because that's our sum. That's our current running sum, and our max is -1, or max is -1. So here we've got -2 versus 4, which is going to be 4 plus -2 is 2 versus 4. And for that, we're going to take 4 because 4 is greater, which leaves us with this subarray left with our sum at 4 and our max at 4. Next we have 4, -1, and that's going to be 3 and -1, which obviously 3 is the one we want. So now we're going from we're still operating from that 4, but our sum now is 3 because it was greater than the -1. So whatever basically is on the left side here, that's going to be the new sum if it's greater than this one. If the next element is greater than the sum of the previous elements in the subarray, then this new sum is equal to the next element. And our max is 4. And then this one, our sum is currently 3. And we're at 2. This gives us 5 and 2. 5 from that. So there we actually now have a new max and a new sum. 5 versus 1. That gives us 6 and 1. Oh, I can see a 6 now. I think that's going to be our big max number. Yep, sum is 6, max is 6. We found the max, but we have to keep iterating because we don't know what the max is until we reach the one more than the last element. So basically, once the index is past the last element, we know to break and return whatever our max value is. So this one we have 6 and -5, which gives us 1 and -5. We still keep 1 because that's greater than -5, which leaves our sum at 1, max at 6. Here's our last iteration. We have 1 and 4. 5 versus 4, which would take 5, but that's not a new max, and since we're at the end of the array, we break and return max. Okay. Hopefully that makes a little more sense. It makes sense to me now after spelling it out like that. I'm glad it kind of came up because I wasn't sure how I was going to do this problem. So hopefully it works in reality. Works great on paper. So our data structure is just a loop, 2 pointers starting at pointers for sum and max, and input array of integers. So for our algorithm, we had to break down this example of arbitrary iterations of our loop. It looks like assign sum to first element of array, assign max to first element of array, invoke for loop from 1 to length of array. We want to start at the second element, not the first, because we already have the first as our sum and max. We're going to say on each iteration, compute new sum. Compute new sum is the max of either the current sum plus current number or current number. Compute new max, it is either current sum or previous max. And then at the end, return max. Okay, let's see if we can code this out. I don't know if they would give us an empty array. So I'm going to run some code here. with a custom test case with just an empty array and also with 1. I want to see what it returns, or what it's expecting to return. Okay, the expected answer for an empty array is negative infinity, I believe that is 6 and 1. Okay, so if so basically we can do let sum equals, how do we get infinity? We get negative infinity. I think this is the deprecated one. Maybe it doesn't. Negative number dot max value. Let's try that out. Sum is equal to, we actually know we want it to be it's expecting negative infinity, so let's give it what it wants, and we'll just start our subarray from, we'll start our loop from 0 instead of 1. And so it's negative number dot max value. Let's see if I return that, if it comes up true for that. That is not correct. You know, since that's our base number, let's just put it in, see what happens. Okay, and max, we'll leave it equal to the same exact thing. This might cause an error because I didn't account for this in the algorithm, but we'll see. Thumbs.length, that was 1. We're not returning sum, we're returning max. So sum is equal to math.max. Remember, math.max, it chooses the largest number from a given set of numbers. It could be 1 or more. I mean, it could be 2 or more. So let's say sum plus nums_i or nums_i. And max is equal to math.max sum or max. Okay, that gave us the right answers. Let's try out some random numbers. We'll do 3, -1, 55, -6, -33, 4, 5, 6. That. To give us the right answer. 57. Okay, that's good. And what happens if we just pass it as 0? Okay, that's good. Let's submit. See how the runtime was. I'm glad that worked because I had no other ideas. Nice, 95%. Pretty good. Okay. So basically, just to iterate over again, what we did here was, in case the algorithm still isn't clicking for you, it's you take the previous sum and you add the current element being iterated on. And if that sum is greater than the next element, I mean, not the next element, but the current element, then you keep that sum, and you do not assign the sum to be the current element. Let me just share my whiteboard again, because I'm having trouble explaining this verbally. Basically, if we have that -2 and 1 and -3 and 4 again, previous sum is -2, and the current element is 1. And then you add them together, because if it's contiguous, it means it's a subarray consisting of all the elements between one index and another index. So we start from -2, and we just start accumulating more elements as we go through the array until one of these elements happens to be greater than the sum, in which case we know to switch our sum accumulator to that next element. So -2 plus 1 is -1, and then the other number is 1. 1 is the greater of the two, so we assign our new sum to be 1, and our max is max is 1. And then we go from 1 to -3, and that's going to be -2 and 3. And in this case, -2 is still greater than -3, so we keep accumulating. So our longest contiguous sum at this point is still -2, 1, -3, like that. But let me go to the next one. So we start with -2, and 4 is the current element. And that 4 plus -2 is 2, and the current element is 4. We take 4 out of that, and we start our new subarray, which is the greatest sum, at 4, because 4 is greater than the subarray before it. The subarray of 4 here is greater than the entirety of the subarray of 4. So we start it here again. So then 4 in the next number, and so on. So hopefully that makes more sense. Yep. Thanks for watching. Have a good day.